Alright, so let's finish up the second half of the Riemann sum video. Yesterday we talked about left rectangles and right rectangles for our Riemann sums. Today we'll look at midpoint rectangles and trapezoidal sums. So essentially yesterday our job was to figure out like how wide each interval should be, and then go from either the left-hand side or the right-hand side to calculate the area of the rectangle. In this case, once we figure out how wide the interval should be, we're going to go from the middle of each rectangle to figure out the height of that rectangle. So, for example, if we have these x sub 0, 1, 2, 3, 4, etc., like we had yesterday, the midpoint would be adding the first two together and then dividing by 2, then adding the next two, dividing by 2, etc., etc. So with the case of, like I said, how we looked at yesterday, if our first 2 points were 1 and 2, the middle of 1 and 2 would be 1.5. So 1 plus 2 is 3, 3 divided by 2, 1.5. That's how you get that number, etc., etc. The middle of 2 and 3 is 2.5, the middle of 3 and 4 is 3.5, so on and so forth. So we'll just jump straight into an example today of what this looks like. It says, you jump out of an airplane before your parachute opens, you fall faster and faster, your acceleration decreases as you fall because of air resistance. The table below gives your acceleration after t seconds, estimate the velocity. Again, this is a table for acceleration. Taking the area under the curve will put us back up to the velocity function because integrals go up and derivatives go down. So, we have 3 directives to use. It wants us to use left and right endpoint rectangles, and then to use midpoint rectangles, just from 0 to 4. So, let's just review from yesterday, the left and right hand rectangles. So if you look at the bases are all the same, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. They all have a base of 1. So as long as all the bases are the same, then for the left, my area would be 1, the length of the base, times all of the numbers from the left. So from the left, we would use the first one, the second one, the third one, the fourth one, and the fifth one, but not the last one. So 9.81 plus 8.03 plus 6.53 plus 5.38 plus 4.41. If I add all those up and multiply by 1, I get out my calculator, 9.81 plus 8.03 plus 6.53 plus 5.38 plus 4.41. I got, if I did this correctly, 34.16. So my estimated velocity after 5 seconds is 34.16 meters per second. Alright, why don't you pause the video here and then try the right endpoint rectangles, and we'll come back together again at the end to do the midpoint rectangles. So pause the video and then unpause it once you have your right endpoint rectangles. Alright, so if you're back with us again from the right, I got that we're using all the numbers except the one on the very left, because from the right we use all the right numbers. And I got that it was 27.96 meters per second. So again, the left endpoint rectangles, because these are decreasing numbers, the left one is an over approximation, and the right endpoint rectangles are an under approximation. For the midpoint rectangles, and this one you have to be careful, because you have to look at the middle, and especially from a table. They like to ask this question a lot on the AP test from a table. If you're looking at a table, you have to have the value in the middle of the table. So some people think like they'll go from 0 to 1. The middle of 0 and 1 is 1/2, but you don't have a value for 1/2, and so you can't use that. Some people like to make it up. They like average these two numbers together and choose that value, but that's not correct. So notice that it just says to use 2 midpoint rectangles from 0 to 4. So I'm actually going to erase this last piece of data off the end. I'm going to get rid of that 5th column because we're not using that. So just from 0 to 4, if I want 2 rectangles, I need to divide that length in half. From 0 to 4, half of that would be 2. So it breaks it 2. One of my rectangles is from 0 to 2, and the other rectangle is from 2 to 4. So 0 to 2, 0 to 2, and the other rectangle is from 2 to 4. Now, the reason we have to do it that way is because the middle of 0 and 2 is 1, and we do have a value for 1 in the table. The middle of 2 and 4 is 3. We do have a value for 3 in the table. So we have to go from something we have a value for if they're asking us to do a midpoint from a table. So down here at the bottom, we have the midpoint area. Midpoint. Now, on these previous cases, because we had 4 rectangles, each one had a base of 1. But in this case, because we only have 2 rectangles and we look at their bases, the length from 0 to 2, and then again from 2 to 4, is actually a length of 2. So notice that my base is no longer going to be 1. Now my base is going to be 2. And the midpoint, the height of the first rectangle from the middle of it is 8.03. Plus the height of the second rectangle from the middle of it is 5.38. And if I get out my calculator, 8.03 plus 5.38 times 2, I got 26.82 meters per second. Now, typically, midpoint is more accurate than either of these, and so I know that it's not perfect because it's actually outside of the range of either of these two. And that's because we cut off this last data point. If we would have cut off that last data point for the left and right rectangles here, it would have worked out a little bit better. But because we didn't, that's why it didn't work out that way. So anyway, this is the process for finding the midpoint, is that you look for what your interval is and then find the middle of that interval, and then use however many rectangles they ask you to use. Let's try another example. So on our last example, we're going to do all 4. We're going to do left, right, midpoint, and trapezoid. And so I want to show you how to do the trapezoidal sums first before we look at that example. So if you remember back to when we were learning about geometry and trapezoidal areas, the area of a trapezoid is 1/2 times the height, and then you add the bases together. So the height is always the distance between the 2 parallel sides, and then the bases. Since our trapezoids are on their sides, if you flip up the ones we have, and typically we kind of cut them off right here, their bases are flat. If you flip this trapezoid up on its side, it looks like this. And so we'll have a new formula, so we say 1/2 times the base, where this is the base down here, and then height 1 plus height 2. So this picture that I just drew, along with that equation, are a good thing to have in your notes. Notice the equation down here. It looks a little intense, but essentially it's just saying that the area is 1/2 times the base, and then the height of the trapezoid from the first side plus the height from the second side. The next one, the height of the trapezoid from the first side plus the second side. The next one. And we're looking at all the different trapezoids. Notice that you can condense that. So the height from the very, very left and the very, very right are only listed one time. But in the middle, you can notice f of x1 is repeated twice. So down here, a little condensed rule would be that you can do the middle sides twice. F of x2 and f of x2 repeated twice, we have 2 of those. F of x3 repeated twice, we have 2 of those. But like I said, the first one and the last one are always only one time. Now the formula itself probably doesn't make a ton of sense right now in terms of what I mean by repeating them twice. So on the next example, I'll draw a picture for you so it makes a little bit more sense. So here's our last example for today, and we're going to do all of the different types of Riemann sums that we've learned so you guys are familiar with all of them. It says Cedarbrook Golf Course is constructing a new green. To estimate the area A of the green, the caretaker draws parallel lines that are 10 feet apart and then measures the width of the green along that line. Determine how many square feet of grass sod must be purchased to cover the green if... And we have these 4 parts. Part A says, if the caretaker is lazy and uses midpoint rectangles to calculate the area. So remember, if we're given a table, we are only able to find midpoint rectangles from from the middle of an actual interval. So it says the caretaker draws parallel lines 10 feet apart. So I know that they only gave us the y values of what the width is, but let's go ahead and label in the x values as well. If they're 10 feet apart, then the first one would be at 0 feet, then 10 feet, 20 feet, 30 feet, 40 feet, 50 feet, 60 feet, 70 feet, and 80 feet. Okay. So, if we look at midpoint rectangles first, we need to have a middle. So from 0 to 10, the middle of that is 5. But notice that I don't have any value in my table for the 5 meter mark or 5 foot mark, which means that that's not the correct interval to use because I don't want to make up a value for 5. I want to be actually given a value. So I can't use from 0 to 10. So instead, my first rectangle for my midpoint approximation is going to be from 0 to 20. All right, and then my next one will be from 20 to 40 because I want all of them to have the same base. So from 0 to 20 has a length of 20. 20 to 40 has a length of 20. 40 to 60, length of 20. 60 to 80, length of 20. So I have 1 rectangle, 2 rectangles, 3 rectangles, and 4 rectangles. So for my midpoint approximation, part A, I'm working with 4 rectangles. They all have a base of 20 feet apart. And then for the midpoint heights, let's look at the middle. The middle of 0 and 20 is 10, so we're going to use that height at 10. The middle of 20 and 40 is 30, so we'll use that height. The middle of 40 and 60 is 50, so we'll use that height. And the middle of 60 and 80 is 70, so we'll use that height. So for my 4 midpoint rectangles, my heights are 28, or I guess these are widths, but that's okay. 28 feet, 62 feet, 55 feet, and 30 feet. If I add all those together and multiply by 20, I get 28 plus 62 plus 55 plus 30, which is 175 square feet of saw that they would have to use. All right. I want you guys to pause the video and I want you to try parts B and C on your own because those are just left and right rectangles. So I'll put the answers up here in just a minute for you guys to look at. But I want you guys to try and calculate those on your own, and then we'll do part D together. And one more thing before you pause the video. Notice that with the midpoint rectangles, we only used 4 of them because we needed the middle. Oops. For left and right rectangles, we can actually use all of them because we're only going to use the left or the right. So I want you to go from the left, and instead of using 4 rectangles, I want you to use 8. Okay, and then go from the right and use 8. All right, so from the left down here, we have each one, now that we're using 8, we have each one as a length of 10. And then we are using all the ones from the left. So I used 0, 28, 50, 62, 60, 55, 51, and 30, and I didn't use the last one because that's the one from the right. So I crossed it off, added all of them together, and multiplied by 10, got 3,360 feet squared. I realized, by the way, when I was doing this one, that I made a mistake on the first one. I forgot to multiply it by the 20 in front, so it was 175 that should have been multiplied by 20, which is 3,500 feet squared. So now go ahead and pause the video again if you haven't already and finish the right rectangles, and then, like I said, we'll come back together again to do the trapezoids. All right, so with the right rectangles, we used all of these points except for the one on the very right. When we added them all together, multiplied by 10, we should get 3,390 feet squared. Notice that the midpoint in this case wasn't actually in the middle of them because it wasn't a strictly increasing or a strictly decreasing function. Notice that if you're looking at this width, it gets wider as you get towards the middle, and then it gets narrower again. So because of that, it's an increasing and decreasing function. So the midpoint in this case actually wasn't super accurate because of that. And so for these last ones, these ones are actually pretty close to each other because if you look at 0 and then you look at 3 at the very ends, like I said, it starts pretty narrow, gets wider in the middle, and then ends up pretty narrow. And so you don't get a gross overestimation or a gross underestimation from the left or right because of that. All right, and then the last one I want to look at is the part D, which is the trapezoidal Riemann sum, and I just want to erase all of this really quick so we can look at a picture of it. So we have 0, 10, 20, 30, 40, 50, 60, 70, and 80. Now, if I was actually going to plot these out, just to show you guys the trapezoid, 0, 10, 20, 30, 40, 50, 60, 70, and 80. And then the height at 0 is 0. We'll go all the way up to 60. So we'll say this is 30. We'll go from there. At 10, it's 28. Then we have 50, 62, 60, 55, 51, 30, and then 3. So if I look at the heights of each of these. So remember the trapezoid, we look at the left and the right. So for the first trapezoid, it actually creates a triangle because of that one height being 0. So I'm going to try and show you the area in a longer, drawn-out version, and then the area in a condensed version. So for this area, we have the formula being 1/2. 1/2 times the height, which is 10, and then the two bases added together. So the height over here, because it doesn't have a height, is 0, and the height over here on the right-hand side was 28. So that's 0 plus 28. So there's my red trapezoid. For the next one, we have this orange one. Okay, so the orange one has a height of 10. Its first leg has a height of 28, and its second leg has a height of 50. So that would be 28 plus 50. The third one, I'll do it in yellow. Hopefully you guys can see this. All right, for this trapezoid, it's 1/2, base of 10. The first height is 50, and the second height is 62. In green, plus 1/2, the height is 10. The first height is 62. The second height is 60, etc., etc., etc. So you could do it this way where it's kind of long and drawn out, ... You could keep looking at all these trapezoids. However, I want you guys to notice the patterns. Notice how it's always a 1/2 because that's the area of a trapezoid. It's always a 10, 10, 10, 10, 10, 10 because all these bases are the same. Remember I told you that trapezoids are the ones that it's not always going to be like that. If they give you a table that don't have nice, perfect, even intervals up here at the top, then our trapezoids could have different lengths for the bases. In this case, though, they're all the same. If they were different, you'd have to do it like this, where you have to do one trapezoid at a time, and then add together all of the areas at the very end. But I want to show you the shortcut because they all have the same base. So, in this red trapezoid, notice that the initial height at 0 didn't touch any other trapezoids, so that's why it's only listed once, like we said in the previous slide for the formula. Then this height at 10, it goes up to 28. Notice that's part of the red trapezoid and the orange one. So here you see 28 in the red trapezoid, and here you see it in the orange one. Then the height at 20 was 50, and notice you see it in the orange one and the yellow one. So here this is the 50 for the orange one, here's the 50 for the yellow one. At 30, the height was 62, and you see it in the yellow one and the green one. So here's 62, here's 62. All right, and it's going to continue like that as we go forward. And then when we get to the very end, the very last trapezoid, let's see if I can draw all these trapezoids really quick. The very last trapezoid, all of these inner heights get repeated. This one gets repeated into trapezoids. This one gets repeated into this one and this one. The only one that doesn't get repeated again is the very last one. So the very first one only touches the very first trapezoid. The very last one only touches the very last trapezoid. All of the ones in the middle touch both of the trapezoids that they are butting up against. So I'm going to condense this formula. And instead of writing out the areas like that, I'm going to say that the whole thing is 1/2 times the base. And again, they all have the same 1/2 from the area of a trapezoid. They all have the same base, which is 10. And then I'm going to list out all of these numbers and add them together. I'm going to multiply all of them by 2, since they all get repeated except for the last one and except for the first one, because those heights don't touch two trapezoids. They only touch the very first and last one. So 0 does not get repeated twice. However, 28 does, so 2 times 28. 2 times 50. 2 times 62. 2 times 60. 2 times 55. 2 times 51. 2 times 30. And then only one of the 3s. I'm not going to add the 3 twice. Again, because that 3 only touches that last trapezoid one time. So I think that's all of them. 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Okay, good. And then the trapezoid, that one. Perfect. All right, so if we add these up in our calculator, give me a minute, I'll kind of talk through this as we're doing it together. 0 plus 2 times 28 plus 2 times 50 plus 2 times 62 plus 2 times 60 plus 2 times 55 plus 2 times 51 plus 2 times 30 plus 3 is equal to 675. If we multiply that by the 10 from the length of the base, we get 6,750. And if we divide that by 2 from the 1/2 for the area of the trapezoid, I get 3,375, what is this, feet? Oh yeah, feet squared. All right, and that is how you find the trapezoidal approximation. So this one was kind of a lengthy one. Most often on the AP test, they don't give you 9 different numbers to work with up here, so it's a little easier to do this piece. Usually there's like 4 or 5 numbers. So, but yes, that's how you do the trapezoidal approximation, and that is the end of the video for today.